Welcome to Review and Preview Problems 1054 to 1060 in the CCG book. 1054 says, in the diagram below, circle M has a radius of 14 feet. So I'm going to go ahead and label that in circle M. And circle A has a radius of 8 feet. Line segment ER is tangent to both circle M and circle A. So remember, when a line is tangent, that it is perpendicular to the radius. If NC is 17 feet, find ER. Okay, so we know that AR is also the radius, which is 8. We know that ME is also the radius, which is 14. So if we subtract this 8, we know that MB is equal to 6 feet. So then we know that MA is equal to 14 plus 17 plus 8, which equals 39 feet. So we know that these two lines are parallel and the same, so we can use the Pythagorean theorem and say, because it's a right triangle, 6 squared plus ER, or AB squared, is equal to 39 squared. We know that 39 squared is 1,521, and when we subtract 36 from that, because of inverse operations, we get x squared is equal to 1,485. We then can take the square root of that answer, and we can say that x is equal to the square root of 1,485, which is approximately 38.54 feet, is approximately the measure of line segment ER. 1055 says, use the sectors in circle D and E to answer the following questions. So we know that the radius is 3 of circle D and the angle is 30 degrees. We know that the angle is still 30 degrees for circle E and the radius increases to 5. What is the ratio of the arc length? So remember, these are both central angles. So our arc length is 30 degrees and 30 to the radius of circle D. Leave your answer in terms of pi. So the first thing we need to do is we need to find the circumference of the circle. So we want to do 2 pi r, and in this case our radius is 3. So 2 pi times 3 gives us 6 pi. We then, our angle is 30 degrees, so we can take 30 over 360, which reduces to 3 over 36, or 1 over 12, and we need to multiply that by our 6 pi, so we get pi over 2 is our ratio, comparing the radius to the arc length. So after we find the arc length of pi over 2, we want to take that arc length and compare it to our radius, so we can have the ratio of the arc length to the radius, which is 3. So when we take pi over 2 and divide that by 3, we get pi over 6 as our actual ratio. What is the ratio of the arc length of the radius to the radius of circle E. So the first thing we need to find is that actual arc length. So to find the arc length, we need to do 2 pi r to find the circumference of the circle, which would be 2 pi times 5, which gives us 10 pi. We then need to multiply that by, our angle is 30 degrees over 360, which is 1/12. So when we multiply those straight across, we get 10 pi over 12, which reduces to 5 pi over 6 for our arc length. We then need to compare that to the radius, so we want to form the ratio. So we're going to take the arc length of 5 pi over 6 and divide that by the radius, which is 5, which simplifies to pi over 6. The ratio of the arc length to the radius of the circle is called a radian. Why will all sectors with a central angle of 30 degrees have the same radian measures? Well, all circles are similar, so we need to remember that circles are similar. Circle D is similar to circle E. Therefore, sector D, so if circles are similar, then they have similar sectors. So we can say that sector D is similar to sector E. The angles are the same, and the radii and arc length are proportional by the same ratio of similarity. So when we write a proportionality equation, we can say that the arc length of circle D compared to the radius of circle D is equivalent to the arc length of E, or the radius of circle E. So in fact, all sectors with 30 degree central angles will be similar. So the ratio of arc length, to the radius, which is this right here equals the radian, will be the same for every 30 degree sector. 1056. In the figure below, find the interior height h of the obtuse triangle. Show all of your work. So the first thing that comes to mind is I need to find this piece right here. And to do that, I'm going to use the Pythagorean theorem. So 20 squared is equal to 12 squared plus x squared, or x, we can say the quantity. If we make this piece x, we can say x plus 9 squared. So remember, when we square x plus 9, we need to write that out 2 times. 12 squared is 144, and 20 squared is 400. So x squared plus 18x plus 81 plus 144 equals 400. We can start combining like terms. So 144 plus 81 equals 225. minus 400 equals negative 175. So then we can factor this, complete the square, use the quadratic formula. So when you use one of the methods, either the quadratic formula, completing the square, factoring, or plugging it into your graphing calculator and solving to see where the x-intercepts are, you see that x equals negative 25 and x equals 7. So a distance of negative 25 does not make sense for x, but 7 does. So we can say that this missing piece of information is 7. We then can find the hypotenuse of this triangle. So we can do 7 squared plus 12 squared equals our hypotenuse squared. So 49 plus 144 equals h to the second power, which gives us 193. In order to solve for that hypotenuse, we take the square root of both sides, and that would tell us that h is approximately 13.89. So when we know that this is 13.89, we now know all three sides of our triangle, and we need to in fact find the height. We can find the angle right here by using some inverse trig, and we can take the opposite over the adjacent side, so the tangent of our angle, by taking 7 over 12 and using the inverse tangent button. And it tells us that the angle is approximately 30.25 degrees. I can find the tangent of the entire angle by taking 9 plus 7, which is 16 over 12, and using the inverse tangent. So I have an angle that equals 53 degrees. The entire angle equals 53 degrees. So if I subtract 30 degrees from that, I know that my angle I'm working with is approximately 23 degrees. So now that I know my hypotenuse, the side opposite, my hypotenuse is cosine, so I can take the cosine of 23 degrees is equal to my side opposite over my hypotenuse. I can then multiply those. Don't forget to do your opposite over your hypotenuse. So the cosine of 23, sorry I have it backwards, is equal to 13.89 divided by the hypotenuse. So multiply the hypotenuse on each side. So we really have 13.89 divided by the cosine of 23, which is approximately 5.4. So remember, in these problems, there's a variety of things you can do. It truly is the process that works the best for you and that you have remembered, but you want to definitely use right triangle trig and the Pythagorean theorem. 1057, a cylinder has a volume of 500 pi centimeters cubed, and it's similar to a smaller cylinder if the scale factor is 1 to 5, so this is the linear scale factor. What is the volume of the smaller cylinder? So remember, volume is cubed. So we have to take our scale factor and cube that. So we get 1 over 125, and we need to multiply that by the volume of our larger figure. So so we get 500 pi over 125. And when we reduce that, we get 4 pi centimeters cubed is the volume of our smaller figure. A 6-year-old house is now worth $175,000 and has an annual appreciation of 5%. What is the multiplier? So appreciation means it's increasing. So 5% written as a decimal is 0.05. To find our multiplier, we want to add 1 to that multiplier, so we get 1.05. What did it cost when it was new? Well, we are talking about a home that is currently worth $175,000. We want to know what it was worth when it was new, so we're going to take the initial cost, multiplier, raised to our 6. When we use inverse operations, and we take 1.05 to the 6th power, then divide by 1.05 that number to the 6th power, we get that the house approximately, when we purchased it, was $130,588. So it's really important that we understand appreciation and value of homes, because you can make money. Write a function of the form f of t equals ab to the t power, where t is the time in years that represents the value of the house since it was new. So a represents our initial cost or amount, so we have 130,588 times our multiplier, which is 1.05, raised to the t power, will give us the value of our home after any number of years. 1059, in the figure below, line segment EX is tangent to circle O. So this forms a 90-degree angle at point X. OE is 20 centimeters. So we have 20 centimeters, and XE is 15 centimeters. What is the area of the circle? Well, the first thing we need to do is find XO, and XO squared plus 15 squared is equal to 20 squared. So when we take 400 and subtract our 225, we get XO squared is equal to 175, which tells us that XO is approximately 13.23. So we could say that our radius is 13.23, or the more exact value would be to write the square root of 175. So to find the area of the circle, we're going to take pi r squared. So when we take pi times the radius, which is 175, and square that, our square root and our square cancel one another out. So if we have 175 pi, we get the area to be about 549.78 centimeters squared. What is the area of the sector bounded by XO and ON? So we know that we're working with a right triangle. So I know that this is a central angle. So I can use my right triangle trig to find out what this angle is. To then subtract that, we know the area of our entire circle, so we just need to divide that by the number of pieces our circle can be cut into. So we take the I'm going to take the opposite over my hypotenuse. Opposite over hypotenuse is cosine. So the cosine of x, or the angle I'm looking for, is equal to 15 over 20. I'm going to use my inverse cosine. So my cosine to the negative first power tells me that my angle is approximately 41.409 degrees. So I can take 360 and divide it by that. Which gives me approximately 8.69. So if I take my area of my circle, 549.78, and divide that by 8.69 pieces, which is about 63 centimeters square. So then they want us to find the region here bounded by EX, EN, and arc NX. So what we can do is we can take the area of the triangle, which is 15 times 13.23 divided by 2, 99.225, subtract out the area of our sector, which is approximately 35.986 centimeters squared. 1060 is a multiple choice question. In the circle below, CD is the diameter. If AE is 10, CE is 4, and AB is 16, what is the radius of the circle? So given this information, we know that the radius cannot probably be more than 10. If half of this is the radius, then half of it is 4. We don't really have enough information, so we would say none of these.